Hi, welcome to my channel Takniki Gyan Guru. Today our topic is Docker. So we'll discuss what is Docker and the key components of Docker, and then we will also compare Docker versus virtual machines, and then we'll go for a demo. In the demo, we will show you how Node.js application is containerized and deployed into the Linux machine, right? So as a Docker, through a Docker. So that demo will also be shown in this class. So let's move to the next slide. So the $1 million question is, what is Docker? So Docker is an open platform for developing, shipping, and running application, right? So open platform is, it is openly available, open source. There is open source. We need not to purchase the Docker as a enterprise platform, right? It is open source, so anybody can use, and that can be used in Linux, Mac OS, or Windows machines, right? So as I said, Docker is an open platform for developing, shipping, and running applications. So Docker is a platform and tool designed to make it easier to create, deploy, and run application using container. So containers allow developers to package up an application with all parts it needs, such as library and other dependencies, and ship it all out as one package. What does this mean actually? This mean is we should create a package where or a box where we can put all everything, like the code, the operating system, and dependencies, libraries, tools, right? Everything should be in one packet, and that packet will be deploy as a container, right? So if we compare, like in virtual machine, we should create the the machine. We should have the machine, and then we have to install the operating system. Top of that, we need to install the web servers or application servers, and then we have to deploy the application with all these dependencies. Now in the container or in the Docker, what we do is everything should be in one package. That package, we create a file. In the file, we mention the operating system. This here, the operating system is very lightweight. We do not need to install the full-fledged operating system. It should be very small OS that will support only your application, right? So this is the Docker. So we can give an example, like suppose you have a magic box. In the magic box you have everything, like the computer program, your code, your tools, your libraries, your softwares, like your application servers, your configurations, your configurations files, or your operating systems, and your code, and the libraries, and any tools is required to install. So everything should be in one magic box, and this magic box is called container, right? And Docker help us to create and manage containers in Windows, Linux, and Mac OS, right? So this is what we call Docker. Now let's discuss the key component of Docker. The first component is container. Container, as we already discussed, the container are lightweight, standalone, and executable software package that includes everything needed to run a piece of software, as we discussed, right? Magic box, where we have our code, runtime, libraries, system tools, right? Everything should be in one package. And container also isolated application from the underlying infrastructure, ensuring consistency and portability. It means the container is work independently, it is isolated. That isolation is very portable and consistent, right, compared than the VM. Next is component is Docker Engine. Docker Engine is a software, or you can say software, or the tools, or your platform, right, where we manage to build and run our containers using the Docker, right? Suppose first of all, in any machine, we need to install the Docker software, right? When we install the Docker, in that Docker will support us to create our containers, right, using the Docker command. So that engine is basically the core software of the Docker, where we can top of that we can create and manage our containers. So sorry, the docker image is basically image are used to create containers. So in the image, suppose we have created a, you know, image where we mention the operating system, everything is configured, and then we create that configured into an image. Using that image we will create a container, right? We will discuss this image later on so that you can understand later. So next is the continuation of the key component. So next, fourth component is docker file. So docker file is basically a script, right? Is a file or a script file where we mention all these instructions, right? Like what will be the operating system, and what will be the, you know, the users. If we have some ports should be defined, we should, you know, give the instruction that we should copy a application code from the host machine to the container. And we also configure or give the instruction of the volume, right? So we have the large files we need to store, so in the container isn't possible, so we should sync one folder from the host machine to the container, so we can configure those instructions should be there in the docker file. So once we have the docker file ready, then using this docker file we'll create an image, so that at the runtime using this image we'll create a container, right? So next one is Docker registry. So Docker registry is basically a registry, right, or is a repository where we will store our images. Once we have the Docker file, we create an image, and that image should be stored somewhere, right? So image should have some versionings, like we create 1.1, 1.2, 1.3. So if suppose 1.3 doesn't work, so we can directly pull the previous version of the image and create the container, right? So we should, you know, have some repository where we should have this image stored, right? And we can version these images, you know. So that is, we say, it has the central repository of Docker images, right? So that we can push our image when it is ready in the local or wherever in CI/CD pipeline, or we can pull, right? Once the application is built and create an image and push into the registry, when we are deploying our application, then we'll pull the image and then, you know, create a container into the environment. The Docker registry is basically the central repository of the image. The last one is container or orchestration, right? So what is orchestration? Orchestration is basically how we manage our container, right? We can scale up the containers, like we have the one or two, when load comes in, so containers should increase, right? To, you know, support the load, right? Currently suppose 10 users are coming and, you know, requesting, and they are, you know, uh, accessing our website, suppose. So now suddenly we have 100 users, right? So earlier it was, you know, one container was sufficient. Now it should create multiple containers. So how the scale will be, you know, managed, right? The scale of availability, right? High availability, like if some container is down, how another container will create in automated fashion, or on the high scale deployment, right? So frequently we are deploying the container, so that should not impact our application, right? So these kind of, you know, management should be done through some orchestration tool. So there are a lot of tools are available, like Kubernetes, Docker Swarm. In the cloud we have the Elastic Kubernetes services. In AWS, in Azure we have Azure Kubernetes services. In the Google cloud we have the Google Kubernetes engine, right? So these orchestration platform we have. So we'll discuss and we'll come up with more videos on the Kubernetes side, right? The all cloud and the bare metal Kubernetes. So for now it is it. Now let's discuss the difference between Docker and virtual machine, right? So let's see what is the difference between these. First difference is operate at application level, right? We operate the application level, and in the virtual machine we operate at the hardware level. So when we create the container, we define the Docker file, all the application level, all the codes and all. But in the virtual machine, we need to create machines, right? Operating systems through some hypervisor, like VMware or some other tools to create the multiple instances. uh, in the Docker has lower resources overhead, right? So we can create our container using very lower resources, like we can say, okay, one container should have zero point 0.5 zero point 0.5 core CPU, or 225 or 516 memory RAM, right? So we can define very small um, resources. Also, it share the host system or operating systems, or it share the resources also, like the volumes we need to share multiple container. That is also possible, but in the virtual machine is a high resource, right? We have to allocate some memory, right? Huge memory, CPUs, and the hard disk. Huge hard disk we need to associate with the VMs. So it is very high resource overhead. Containers provide better performance. VM, introduce some performance overhead also. So if we need some better performance, we need to increase the resources for VM. Containers are high portable, right? We can, we have the Docker file. We just can create the same containers different, across all different environment, and we can create different environment also. VM is less portable here. Container start quickly, right? As soon as we deploy, then we can start. It should not reboot whole operating system, because it's very small OS that support only the application. But when the VM, we should start and reboot whole the machines, right? The full OS should be restarted. And for some use cases, right, in Docker, we it is well suited for microservice architecture, continuous integration, and deployment scenarios. And for the virtual machine, as the traditional use of running multiple application with different operating system on a single physical server, like if we have the legacy application, right, we have multi-layered applications. The multi-layer application will work on the virtual machine. The application, the um, front end application would be multiple servers, like in high availability. So we have the load balancer. Top of that, multiple servers are associated. Then the second layer is business logic layer, where we have other services are involved. Then the database layer. So multi-layer application have the traditional virtual machines. Now move to the next slide. Okay, so this slide says demo, right? So in the demo, we will containerize the Node.js application in Ubuntu and using the Docker. So we will containerize the Node.js using the Docker, and then we'll deploy that the container into the Linux box, right? So let's go to the VS Code to understand the code first. Then we will create a container. Okay, now we are in VS Code. So let's see and have some understanding on the code. So we have created a sample Node.js application where we have the package log.json, package.json, and the app.js, right? The package.json, we have the configuration, like the scripts, like how our application will work, like node mon app.js. And in the app, well, in the app.js, we have the actual code. So here we just create some small, student management system, where we are publishing this code into 8082 port, right? Created a variable, the array of students. In this section, we are just creating students. This is one of the API we are publishing, post method, where we are just creating students. We are creating a variable of student. We are getting the information from the request, like the student's length, name, age, and grade. So this will create a ID. And once we get the students, we are creating a student or we are adding one student to the array, right? Whenever we call this API, it will create one students and push into the array, save into the array. And another next one is we are getting all the students, right, from the array. So using this API, get API, um, we are just returning all the students, correct. And next is we are getting, students by his student ID, right? So we are finding student based on his input parameter student ID. It is searching. If doesn't found, it return student not found, otherwise it return the student, correct. Now updating the students, again we are getting the student ID, and based on the student ID it will return, you know updated student ID, otherwise return student not found. Delete, we are just deleting a student from here. And this application will run on localhost. The port is 8082. This is just a small application we have created in Node.js. How we'll deploy? This is the Docker file. Actually, we have the Docker. Using this Docker file, as I said, right, we need to create a Docker file. Using the Docker file, we'll create an image, and that image will be used to create a container. So how the Docker file is created? We would need a base image, right? Base image is basically a small operating system where all the packages are installed for your applications. So we are, running a Node.js. That's why we are, you know, getting a Node colon 18.16.0 hyphen alpine 3.17, right? This is the base image we are taking for different. There are a lot of other, Node.js OS is available, or base image is available. We can use this, right? Now once we have the base image, we what we'll do is we'll run some commands. These are the some run we can create. We can run some command, right? Make dir one of the command, right, where we are creating a folder. So we are, how we will create a folder? First of all, we need to type run, and then our command should be make dir and hyphen p and slash opt slash app. This folder will be created into this operating system, right? And our working directory. So once we create this folder, our working directory should be app, opt opt slash app. So if it is there, then we will copy, because our file is there. We are running the Docker file in the same application. We need to put our Docker file in the application, inside the application, right? So that we can directly copy our package.json and package log.json to dot means the current directory. Our current directory is app.app, because we can define work directory means our current directory. So it will copy the files, these two files from this here to dot means the working directory inside the container. It will get the files from host drive, and then put into your working directory inside the container. Now once it is run, your applications are already moved to the container. Now we are again running one more command, npm install. The npm install will install all the required packages or dependencies of your Node.js application, right? So it will install everything in all the modules and packages or libraries. Everything will be installed through run install. Once everything is ready, right, then we can also copy our other files like app.js. We just created one. There may be, lot of files should be there when we are creating a full-fledged application. So all the files should be copy from here to dot means your working directory opt.app. So it will install. Now we are exposing, right, 8082. So this port will be exposed, and then npm start. So this command will be start, like your application should run, right? So start, the npm start will run your application into your port 8082. So once your Docker file is ready, right, then you will have to go to the Linux environment and then run this one. It will create a Docker image, correct. Now we would need a Linux box, right? So I don't have Linux box. We'll later on discuss and cloud and other things, but we'll in the previous class, I have shown you one demo where we have seen how we can create a Linux box inside the VM, right? Similarly, using the Vagrant. So we will use the same method. We have already created a Vagrant, a one Linux box using Vagrant. Now we will log in, and we have also map this folder to our Linux box folder. So I'll show you a little code on this. So a little bit brief of the Vagrant file. Using this Vagrant file, we can create our Linux box. We have already discussed all these things. Now we'll discuss only the sync, the folder. So I have just mentioned config.vm.sync folder where we are configuring the our current directory where the Vagrant file is, and inside the home vagrant.node.js, right? This Vagrant file is inside the same folder. Now this folder will be synced to this one, the home vagrant node.js. So we'll go to the Linux box and we'll see how it works, right? So this when we use vagrant up, the new Linux boxes will be created. Let's see. Now we move to the command prompt. So here we have already set up the vagrant, and we have already discussed in another class, previous class, how to install vagrant, you know right? Full video is there. If somebody wants to see, please check that video. So let's print a vagrant file, right? You can see config.vm sync folder is host drive. We are just mapping this host drive folder into Windows, and home vagrant node.js, this folder inside the Linux box, right? So let's see dir. We have the vagrant or host drive and vagrant file, right? Vagrant file, we mentioned this sync drive like host, and this is the Linux box drive, and this is the Windows folder, correct? So now this host drive folder will be synced to your Linux box home vagrant node.js folder, correct? Let's see. Let's you know run vagrant command. Vagrant up, this will you know start your Linux box into your system. So we are creating Ubuntu version 20.004. Yeah, Ubuntu 20.04. So it will reboot the system and create a Linux box for us. So then we will containerize. Also, we have already installed the Docker inside it. So we are not going and installing the Docker. So if somebody wants to see how to install the Docker, just comment. Just comment. We'll definitely come up with some videos or try to reply in the same comment. Please do that if you really interested to install the Docker as well. Okay, so Linux box is ready. Let's run vagrant sh. This will log into your Linux box, your Ubuntu box. So let's log in and check. Okay, now you can see you are the vegan user. You have logged into the node VM Ubuntu box. Now let's check ls. See, the node.js folder is already available. Let's cd node.js ls, again node.js cd. Okay, ls. Now you can see the app.js is available, Docker file is available, package.json, package log.json, right? Let's see one by one. Vim app.js. Sorry, I guess save app.js. No, app, sorry, it was my mistake, vim app.js. See, the same code is there. We are just creating one student, getting all the students, um, getting student by his id, the same code, right? The app.js, and we'll check the docker file as well. Vim docker file, the same code, right? From node 18.6.0 alpine, we are creating a directory opt slash app. Current directory should would be opt.app. Now copying over these files, and then we are running the npm install, so that all the packages should be installed, or dependencies packages will be installed required, and copying all the folder into this app folder, exposing 8082 port, and then starting our applications. So let's now we have ready with, let's check docker is installed or not. Docker version is already installed, 24.0.7. So we have already installed the docker. If somebody wants to, they stuck in between and they want to see how the docker should be installed, just comment me. I will give you or guide you how to install the docker. So this part is skipped in this video. Now let's go further and create a, using a docker file, create an image. So how we will create an image? Let's say docker build. You need to give some name, student hyphen t hyphen t. Uh, Give me a minute. We need to check the sudo command also. Sudo is docker build hyphen t student, and okay. So sudo, because the user should have the access, privilege or permission to run this docker command, right? So that's why we use sudo docker build. So docker build command will build your application and create an image, right? So we should give a name of the image. So the image name should be the student, and the dot should be the current folder. So the docker file is exist in our current folder, right? Vim docker. So it will take the docker file from the current folder. If you have your docker file somewhere else, you can put the path of this docker file. So if you run this command, press enter, it will create an image, right? So here we are not pushing this image into somewhere some registry. We will use this image, same image here, and then we will use it, right? So we are not going to push or pull image into somewhere else. So let's see docker. Let's check docker. Sorry, sudo should be required. Sudo docker images. You see, the students image has been created. Image id is this. 30-second back, this image has been created, right? This is the local repository inside the VM. So we are not pushing the our image, but when we will use the CI/CD pipeline, definitely we have to push this image into some registry, either in cloud or somewhere else, right? Docker hub, or ECR, elastic kubernetes registry, right? Elastic Container Registry, or ACR, Azure Container Registry. So we need to push and pull the image from there. So currently we are working on the same Linux box, so we will use the same repository, local repository, right? So it is in the same repository, student. Now we need to create a container of it, right? So how we will create a container? So we need to say sudo docker run hyphen IT, and we need to push the port, right? So for P, we need to say port. Sorry, P means port, and we the container 8082 and host 8082, same port, right? So this one, and we need to give the name of student, right? Container name. Now if we run this, the image name, right? So we are running the image student. Then if we run this one, it will create a container inside our Linux box. So container is already created. Now let's the application is running on localhost 8082. So now let's move to the browser and see how we can access like local host nothing. So we can get all the student using this one, right? So currently there is no student, so it shows nothing, right? So let's create some one. I have already created some PowerShell command to access this API. Invoke web request hyphen URI and our localhost 8082 student method post header this, and body was name, and name JSON duo age and grade. We are passing this one. This will create a student into the application. You can see, yeah, it is created. Now you can go and check again. Yeah, the student is created now. Again, if we can create one more, like say one is 24, grade A. Now create again and and check in the browser. You can see one ID is two ID, and you can get method. You can use get method, or if you can go to the browser and say if you want student hyphen one, right? So ID one should be display. ID one we have two, ID two. So two will be display here. Now let's move to the command again, right? If you can see, because it is already running, let's log into another command prompt. Cd the folder path and vagrant ssh. Just log into another shell so that we can see the container is already created. Okay, so ls, let's see the command called sudo docker images. That will show you the image. Now docker sudo docker, yes, see, this is the container id, image name is student, command this one is created, port is 8082, name is this is. So this container is already running, right? And if you can say docker ps hyphen a, that will show you all the um, stopped container or archived container or running container if we use this docker psa, right? So container is running. Now let's see if we are stopping this, then docker sudo sudo docker ps. See, no container is running because we stopped it. Now docker -a, you can see all container is stopped. Exited means stopped. So the container is running now. If you go to the browser, you can see the application is not running now because container is stopped. So the demo is done. We have already shown you how to, you know, containerize our Node.js application deploy into Linux boxes. So, so this will end to our video. Now, if you like this video and you want more video, any video, as always says in all my videos, like if you want particular video in particular section, just comment us. We will definitely come up with those topics. Thank you so much for watching my video. Take care. Bye.